In this video, we're going to continue our notes in section 2.5 on the derivative. And here we're going to look at some more rules. So in this section, there's a lot of derivative rules that are coming at us. So it's just about taking it slow, working on a bunch of practice problems, and then you'll start to see what rule you'll need to use for what function. So let's get started filling in these last three rules. So product rule. So product rule is if we're computing a derivative of a product of two functions. Suppose we have f of x times g of x, and we want to take the derivative of this product. Then the product rule states that the derivative of this product will be the derivative of the first function times the second function plus the first function times the derivative of the second function. So if we want to write this in a bit more clear notation, we could write our product, f of x times g of x. The derivative is equal to the derivative of f times g plus f times the derivative of g. Now, one thing I want to state here is that summing, adding up two functions is commutative, meaning I could add up in either order. So I could have written instead derivative of the second function times the first plus the first function times plus the derivative of the first times the second. So it doesn't matter which order we use here, but when we're computing this derivative of a product, we always have the derivative of each of the terms in our product times the other term. All right, so now let's take a look at the next rule. So our next rule is the quotient rule. So this comes in if we have a function that involves a quotient of two functions. So if I have, let's say, f of x in the numerator over g of x, then the derivative of this quotient is the following. I have the denominator function, so g of x, times the derivative of the function in the numerator. Then I have a minus the function in the numerator times the function in the denominator over the function in the denominator squared. Okay, so I want us to just pause and sit with this for a little bit. So there's a lot going on here, but the more of these functions that you see and the more derivatives that you compute, this will become a lot more familiar. One other thing I want to say about this is you might think, where is this coming from? Well, these rules, like quotient rule, product rule, all the rules that we looked at, again, are coming from that limit definition of the derivative. So if you were to write a basic form of a quotient like this and compute the derivative using that limit definition, so you'd set up a, let me get this right in here, a quotient or a difference quotient with my quotient function. So I'd have my term with the x plus h minus my terms with the x like this, all over h limit as h goes to 0. If you were to compute this big limit, what you would get in the end is this function. So if you're curious, I'd suggest you maybe Google around. You could find a proof of that, or feel free to email me and I'd be happy to work through that with you or create a video to show you how that is derived. But so that's where these are coming from. So it's not just coming from, nowhere. It's coming from using that limit definition. But let me give you one other little nugget of knowledge here, and that is a way of memorizing this quotient rule. So one thing that I say to myself when I'm doing this is the following. So the derivative of a quotient is low d high minus high d low over low low. We'll work through that. So low d high, so it starts on the bottom, low d high. So the low function, the denominator function times the derivative of the numerator, so low derivative of high, low d high, minus high numerator f function over d low, g prime, over low low. So let me write that out. Low, d high, so bottom function, derivative of high of numerator function, minus high, d low, over low low, or low squared. So that's a mnemonic that's helpful for memorizing this quotient rule. And it's just fun to say low d high minus high d low over low low. So I encourage you to pause the video and try that for yourself. All right, and so now our final rule for this section is the chain rule. So chain rule involves a composition of functions. So suppose we have a function f, and into function f, I put another function g of x. And I want to take the derivative of this composition. Then the derivative of this function is derivative of f with respect to g of x times, not done yet, the derivative of g of x. So this one might sneak up on us sometimes. Many functions are composition. And so the more examples that you do of these, the more practice you get, the more comfortable you'll be with computing that. All right, so again, these were a lot of new rules coming at you. So I suggest that you rewatch any parts of this video to help get a sense of the structure of some of these basic derivative rules. And then from there, please continue watching some examples and then work on some practice problems to help you get more comfortable and familiar with using these derivative rules. All right, thanks for watching.